3, 2, 1. Liftoff. 32 minutes past the hour. Liftoff.
What do you do when you want to observe somewhere so deep in space that you can never reach it? You send a space observation station. NASA has done precisely that by sending the James Webb Space Telescope to deep space so that it can help us see more of our universe.
There are no limits to the human spirit. I thought I would see the end of physics, but now I think the wonder of discovery will continue long after I am gone.
One of the places the Space Telescope will be pointed at is the very edge of the universe. The findings at the edge of the universe promises to be scary. What will the first telescope see at the edge of the universe? How does it affect you personally? Join us as we explore the terrifying discovery by the James Webb Space Telescope at the edge of the universe that changes everything. Have you ever wanted to complete a task but wished you had the proper tools? Perhaps you wanted to geek on your smartphone but lacked the precision tools to crack it open, or badly need a flamethrower. Scientists worldwide were once in that position until the launch of the James Webb Space Telescope. The universe contains a lot of mysteries that scientists are trying to unravel. One of the most puzzling is the question of how the universe itself started. While there are many hypotheses, they still need to be proven, and the proof centers on one thing: finding out exactly what happened at the beginning of the universe. That is no small feat, as it requires the best equipment humankind has ever made. The tool must be able to see the edge of the universe to study some of the oldest objects or formations in existence. Some of these objects have existed for billions of years, and it's time to demystify them. This is where the JWST comes in. The JWST is simply the most powerful telescope humans have ever dreamed up. The father of the telescope, Galileo Galilei, must be proud of how far we have brought his craft. However, that progress comes at a steep price, $10 billion, and with a lot of panicky moments during the launch. Since everything has gone well with the launch and setting up of the JWST in its permanent orbit, NASA can sit back and enjoy the massive scientific returns from the massive space observatory, and the JWST has been delivering. In the short time scientists have had a go at it, the JWST has revealed truly shocking things about our universe, many of which the scientists didn't see coming. At this rate, it is not an exaggeration to say the JWST will challenge everything we thought we knew about the universe. Just as expected, the JWST is already taking us far back into the past and nearer to the edge of the universe. Scientists call this part of the time a glimpse of the early universe. This is due to its ability to detect the faint light of incredibly distant galaxies as they glow in infrared light, a wavelength that is invisible to the human eye. As such, the image we are talking about here has been helping astronomers to better understand how galaxies formed and evolved in the early days of the universe. The image that has excited scientists captured a galaxy cluster MAX 0647 as well as the distant galaxy MAX 0647JD. The cluster appears as a dazzling grouping of galaxies that shine like precious gems against the dark backdrop of space. The distant galaxy is visible thanks to a certain type of observational phenomenon due to the cluster. This phenomenon is called gravitational lensing, and it occurs when galaxies in the foreground act like magnifying glasses, allowing us to see the more distant objects behind them. Small boxes were used to pinpoint the galaxy MAX 0647JD, and more detailed images of the galaxy are aligned along the right side of the image. The cluster essentially triple lensed the galaxy, magnifying it and causing it to appear in 3 separate places within the image. Each box on the right showcases different details of the galaxy. While MAX 0647JD was discovered 10 years ago using the Hubble Space Telescope, it took the JWST not long to reveal something surprising about the cluster. There are 2 features. Here is what happened. Using the Hubble, it was just the pale red dot. We could tell it was really small, just a tiny galaxy in the first 400 million years of the universe. However, with the powerful JWST, scientists were able to resolve 2 objects. However, a puzzle remains. Are these 2 galaxies or 2 clumps of stars within a galaxy? They don't know yet, but guess what they are banking on to get the answers? The JWST. These are not even the most distant objects the JWST has discovered. That honor goes to one of the earliest galaxies formed not long after the Big Bang. This particular galaxy was captured at about only 350 million years after the Big Bang, or after the universe began. The galaxy called Glass Z12 and another galaxy formed about 450 million years after the Big Bang was found not long after the powerful Space Observatory began its infrared observations of the cosmos. Before this, the earliest galaxy observed was GNZ11, which existed 400 million years after the Big Bang and was spotted by the Hubble Space Telescope in 2016. In fact, the scientists using the JWST said as soon as they started taking data, they came to the realization that there were many more distant galaxies than they were expecting. Basically, the universe produced galaxies faster and earlier than the researchers thought. Just a few 100 million years after the Big Bang, there are already lots of galaxies. The JWST has just opened up a new frontier, giving us a front-seat view that helps us better understand how it all began. Both galaxies have a sphere or disk-like shapes, but in size, they are just a tiny percentage of the size of the Milky Way galaxy. The two galaxies are very distant from us, but they are extremely bright and generate stars very rapidly. Further research has suggested that galaxies may have begun popping up in the universe just 100 million years after the Big Bang, which took place 13.8 billion years ago. This timeline challenges the theories astronomers have propounded about how and when the first galaxies formed. The puzzling thing was that the early universe was undeniably chaotic and crowded, but the structure of the two galaxies turned out to be calm and orderly. Do you know one other thing that has baffled these scientists? It is the sheer amount of brightness in these two galaxies. One possibility is that the galaxies were massive and contained a lot of low-mass stars, which is similar to the types of galaxies that formed later on in the universe. Another possibility is actually the opposite: smaller galaxies with fewer but extremely bright stars. These luminous objects, which scientists call population 3 stars, have long been theorized as the first stars ever born in the cosmos. The first stars in the universe are believed to have been blazing hot and comprised of hydrogen and helium. The stars that came afterwards must have contained heavier elements that were created when the first stars exploded. So far, no population 3 stars have ever been spotted within our local universe. But scientists are banking on powerful telescopes like the JWST that can peer back into the distant universe, effectively looking back in time to see the first population 3 stars one day. It won't be surprising if the older of the two galaxies, Glass Z12, contains population 3 stars. The JWST continues to destroy records set by former telescopes, and the surprising thing is that it's doing so within the short time that it's begun fully functioning. While you might be appropriately wowed by the two distant objects already mentioned, there is even more, like the galaxy candidate Sears 93316. This object formed about 250 million years after the Big Bang and set a record redshift of Z16.7. This discovery is a massive deal, demonstrating the power of the beast developed and launched by NASA. SEERS stands for Cosmic Evolution Early Release Science Survey. It is a special program meant for imaging with JWST. Researchers will confirm the redshift with follow-up observations using spectroscopy. This is why they still refer to it as a galaxy candidate. However, the study has already determined that Sears 93316 can't be a low-mass star or an unobstructed active galactic nucleus. This is based on imaging data from the NIRCam, JWST's primary imager. After the Big Bang took place, the universe entered what is known as the Dark Ages. This is the time before any of the stars you see today were born. However, the observations of this galaxy push observations back to the time when scientists thought the first galaxies ever to exist were being formed. NASA says the JWST can detect galaxies at redshifts greater than 20, which correspond to less than 200 million years after the Big Bang. However, the fact is that these galaxies will likely be extremely hard to find. But with the detection of Sears 93316, scientists hope that they may exist. Now, if you have been baffled by redshift and shifted light, here is what they mean. Following the Big Bang, the universe was like a hot soup of particles like protons, neutrons, and electrons. However, as the universe began to cool, the protons and neutrons began combining into ionized atoms of hydrogen and some helium. In these ionized form, the atoms of hydrogen and helium attracted electrons, turning them into neutral atoms. This allowed light to travel freely for the first time in the universe, as the light was no longer scattering off free electrons. This was a turning point in the universe, as for the first time ever, it was no longer opaque. But wait, it would take some time, maybe a few 100 million years after the Big Bang, before the first sources of light would start to form, bringing to a close the pages of the cosmic dark ages. So this is quite interesting, as it means the universe was ready to transmit light before the sources of light were formed. So what did the universe's first light, that is, the stars that fuse the existing hydrogen atoms into more helium, look like? We don't know that yet. And when exactly did these first stars form? We don't know that either. Again, these are questions scientists are waiting for the JWST to answer. But what about shifted light? Well, imagine light leaving the first stars and galaxies nearly 13.6 billion years ago and traveling through space and time to reach our telescopes. What this means is that we are seeing these objects as they were when the light first left them 13.6 billion years ago. However, by the time this light gets to us, its color or wavelength would have been shifted towards the red, something called a redshift. In this particular case of very distant objects, Einstein's general relativity applies. It says because the universe expands, the space between objects actually stretches, causing objects to move away from each other. Furthermore, any light in that space will also stretch, and the light's wavelength will shift to longer wavelengths. This can make distant objects very dim or invisible at visible wavelengths of light because that light reaches us as infrared light. So when they say redshift, it means that light that is emitted by these first stars and galaxies as visible or ultraviolet light actually gets shifted to redder wavelengths by the time we see it from the Earth. For very high redshifts, that is, the farthest objects from us, that visible light is generally shifted into the near and mid-infrared part of the electromagnetic spectrum. For that reason, to see the first stars and galaxies, we need a powerful near and mid-infrared telescope, which is exactly what Webb is. Another distant object that the JWST has clarified is what is popularly called the Pillars of Creation. This was first captured by Hubble in 1995. While it was impressive at the time, the JWST has done it far better. The three-dimensional pillars resemble rock formations but are very permeable. The columns comprise cool interstellar gas and dust that sometimes appears semi-transparent in near-infrared light. Thanks to the images taken in 1995 and 2014, JWST's new image of the Pillars of Creation will assist researchers in improving their models of how stars formed by identifying far more precise counts of newly formed stars, along with the quantities of gas and dust in the region. With time, scientists will gain a clearer understanding of how stars form and burst out of these dusty clouds over millions of years. The second time the JWST took an image of the Pillars of Creation, it used the mid-infrared instrument or MIRI. The result was a somber and chilling production. Another one in the set of images showed the Nebula 30 Doradus in great detail. It is also known as the Tarantula Nebula and is one of the largest and brightest star-forming regions in the galaxies nearest to our Milky Way. The Tarantula Nebula is located 161,000 light-years away in the Large Magellanic Cloud Galaxy. The name is inspired by the long dusty filaments resembling spiders' legs in older images. The picture shows the stellar nursery in another level of clarity, showing tens of thousands of young stars that were previously shrouded in cosmic dust, hence never seen before. For many people, the most memorable part of the JWST is the size. The JWST's gold-plated mirrors have a total diameter of 6.5 meters, much larger than Hubble's 2.4-meter diameter plate. This means the JWST will have approximately a 15 times wider view than Hubble. You've heard different comparisons of JWST with Hubble, but the two iconic telescopes function differently. The Hubble's primary focus is on both visible and ultraviolet light. It has some infrared capability, but it is nowhere near the extent to which the JWST can. In fact, the JWST is designed to work on the infrared spectrum. This means it can't see in ultraviolet light as the Hubble, but it can focus on bright objects like very distant galaxies. But distant galaxies are not the limit for JWST. It can observe objects that are over 13.6 billion light-years away. This means we will look back 13.6 billion years, which brings us between 100 and 215 million years close to the Big Bang. Most of the size of the JWST is due to its large sun shield. It is so big that NASA engineers had to design it to unfold during the launch because of space limitation on the launch vehicle, and then unfurl it while it journeyed to the permanent orbit. This is used on all space telescopes, but is especially important with the JWST due to its infrared cameras. If it isn't kept cool enough, it stands the risk of blinding itself to the lights of objects it is trying to observe. One other key difference between the two satellites is their distance. The Hubble telescope orbited above Earth's atmosphere but was near enough to be approached if repairs needed to be done. But the JWST is many magnitudes further away, around 1.5 million kilometers away. That places it farther than any human can and has ventured, meaning nobody can call on it for a repair if something goes wrong. One of the things scientists have discovered at the very edge of the universe is a galaxy named Able 2744Y1. This galaxy is special for many reasons. Able 2744Y1 is so far away that light from it gets to us after 13 billion years of traveling. Remember, the universe is estimated to be 13.8 billion years old. One thing about Able 2744Y1 is that we are seeing it as it was when it was only 650 million years old. This is true of all distant objects in space because the light from them has taken so long to reach us here on Earth. Able 2744Y1 was discovered using a total of 3 telescopes: Spitzer, Chandra, and Hubble. But just how did 3 telescopes come together to discover a single item? Well, the Hubble captures images in visible and near-infrared light, while the Spitzer has the advantage of using the infrared portion of the electromagnetic spectrum. Scientists use Chandra to collect additional data using X-ray wavelengths. By combining data from these 3 space telescopes, astronomers are able to see galaxies up to 100 times more distant than any of the observatories could have done individually. The astronomers attached to the Instituto de Astrofísica de Canarias (IAC) and La Laguna University in Spain started with the Hubble, which detects the galaxy in question. This is then followed by the Spitzer, whose instruments are used to calculate the distance of the object where it's located. The telescope also helps to determine how many stars are in the galaxy. The scientists also used a method known as gravitational lensing when they photographed Able 2744Y1. The underlying principle is similar to how a magnifying glass bends sunlight, because images from distant galaxies are put into focus by galaxies closer to Earth. This natural telescope to view the most distant objects in the universe was first predicted by Albert Einstein in his general theory of relativity. So how large is this galaxy? Astronomers say Able 2744Y1 is quite small in size. It is about 50 times smaller than our own Milky Way galaxy, or about 2,300 light-years in width. However, what this galaxy lacks in size, it makes up in the rate of star production. It generates stars at a rate 10 times faster than the Milky Way, but that is typical of galaxies in the young universe. The Able 2744Y1 galaxy has a redshift of 8. Redshift is a way of measuring the degree to which an object's light has been shifted to redder wavelengths due to the expansion of the universe. In comparison, the farthest confirmed galaxy before the discovery of Able 2744Y1 has a redshift of more than 7. Remember we said that the universe is 46.1 billion light-years in radius. That is the limit of the observable universe. There is much more out there. How do we know what lies out there beyond the observable universe? We can make inferences based on the laws of physics that we know and by using the things we can measure within our observable universe. For instance, we observe that the universe is spatially flat on the largest scales. It's neither positively nor negatively curved to a precision of 0.25%. If our current laws of physics are correct, we can set limits on how large, at least, the universe must be before it curves back on itself. We can get the best data for our extrapolation from observations from the Sloan Digital Sky Survey and the Planck satellite. The two sources suggest that if the universe does curve back in on itself and close, the part we can see is so indistinguishable from uncurved, it must be at least 250 times the radius of the observable part. This leads to the conclusion that the unobservable universe, assuming bearing any topological weirdness, must be at least 23 trillion light-years in diameter. It must contain a volume of space that is over 15 million times as large as the volume we can observe. However, there are compelling arguments that the unobservable universe should be significantly even bigger than that. How? It's like this. The Hot Big Bang might mark the beginning of the observable universe as we know it, but it doesn't mark the birth of space and time itself. This is because before the Big Bang, the universe underwent a period of cosmic inflation. Rather than being filled with matter and radiation and being hot, the universe was filled with energy inherent to space itself, expanding at a constant exponential rate and creating new space so quickly that the smallest physical length scale, the Planck length, would be stretched to the size of the presently observable universe every 10 raised to the power of -32 seconds. Sure, inflation stopped in our region of the universe. However, three key questions that directly affect how large our universe is remain unanswered. These questions deal with whether the universe is infinite or not. They are: 1. How big was the region of the universe post-inflation that created our hot Big Bang? 2. Is the idea of eternal inflation, where the universe inflates eternally into the future in at least some regions, correct? And 3. How long did inflation go on before its end and the resultant hot Big Bang? It is possible that the universe where inflation occurred barely attained a size larger than what we can observe. Perhaps any year from now, the evidence for an edge to where inflation happened will materialize, and we will have to adjust our perception of the universe again. But it is just possible that there are plenty of universes out there just like ours, following the same laws of physics and having the same types of physical, cosmic structures. This raises the tantalizing possibility of complex life in one of the numerous worlds out there. There should also be a finite size and scale to the bubble in which inflation ended, and an exponentially massive number of such bubbles contained within the larger inflating spacetime. From the most distant galaxy ever captured, we move to another distant object, this time a supernova. What is the most distant supernova ever spotted by astronomers? That title goes to DES 16C2NM. If you are wondering what is up with the name, it is because the supernova was first spotted by the Dark Energy Survey, which is a research work that seeks to better understand the mysterious force thought to be responsible for how the universe's expansion is accelerating. Supernovas are some of the biggest explosions we can ever have. Picture an atomic bomb, but with infinitely more bang. They are like the last valiant effort made by stars before they die. The stars here are at least 5 times bigger than our own sun. Here is how stars work so that we understand how they die. Massive stars basically burn humongous amounts of nuclear fuel at their cores. This leads to the release of tons of energy, and as a result, the center gets very, very hot. This heat generates pressure, and the pressure created by a star's nuclear burning also keeps that star from collapsing. When you see a star in the sky, it's because there's a balance between two opposite forces. On the one side, the star's gravity tries to squeeze the star into the smallest, tightest ball possible. On the other side, the nuclear fuel burning in the star's core produces a strong outward counterpressure. This outward push resists the inward squeeze of gravity. But when the fuel runs out, the star starts to change its behavior. It begins to cool off, causing a drop in pressure. This goes on until gravity eventually wins and the star collapses in a spectacular fashion. This is a brisk affair as the collapse occurs in a short period of time. It would be like the Earth collapsing in just 15 seconds. This collapse creates shockwaves that cause the outer portion of the star to explode. You can also have a supernova when two stars collide. Supernovas are not that common. You could have 2 or 3 in a century, so it is always special when a supernova occurs. DES 16C2NM was detected in 2016, and scientists confirmed a supernova like that is extremely rare. It is like the very extreme version of what you call normal supernovas. The The discovery was made by a team of international astronomers, and they say the explosion took place about 10.5 billion years ago. This means the light from the explosion has been traveling to us for more than 3/4 of the existence of the universe itself. What is even more mind-boggling is that the location of the supernova is even more than that, thanks to the expansion of the universe. The team also enlisted the help of 3 powerful telescopes: the Very Large Telescope, Magellan, and the Keck Observatory. It involved more than 400 scientists from all over the world and took 5 years with 525 nights of observation. While the scientists ran into many troubles to locate the supernova, the effort will pay off in many ways. The extreme distance of DES 16C2NM gives the scientific community a totally new insight into the nature of superluminous supernovas, or SLSN. Scientists can determine the amount of metals produced in the explosion by studying the ultraviolet light from the SLSN. It can also reveal the temperature at which the explosion occurs. These 2 things here are key to the understanding of what causes and drives these massive cosmic explosions. However, it may not be long before another, more distant supernova is found, because scientists are out looking for them, spurred on by the extraordinary discovery of DES 16C2NM. How about a whole galaxy discovered through luck? Sometimes the universe turns up things by surprise, and one such unexpected gift is Bedin-1. The universe is vast, but it contains so many objects that it can't help stacking them behind one another. You'll find nebulae, star clusters, and galaxies all one behind another. This was exactly the case when the Hubble was used to photograph a globular star cluster named NGC 6752. This cluster is located 13,000 light-years away from us in the Milky Way galaxy. The scientists were shocked and also excited to find a totally unknown galaxy behind the cluster of stars. The galaxy is a spheroidal dwarf and is located about 30 million light-years away, meaning it is about 2,300 times farther than the cluster in front of it. This means the new dwarf galaxy is relatively close. Spheroidal dwarfs are known for their small size, low luminosity, lack of dust, and very old collection of stars. This new galaxy was nicknamed Bedin-1 after one of the researchers that found it. It is called a dwarf because of its size. It is about 3,000 light-years at its greatest width, meaning it is barely 1/30th of our own Milky Way. It is about 1,000 times dimmer as well. Bedin-1 is about 13 billion years old and very isolated. It is about 2 million light-years from its closest large galaxy, the NGC 6744. This makes it more or less a living fossil from the early days of the universe. Let's hear what you think of the vast universe in the comments section below.